Namaste, welcome to our Group 1 services orientation classes. Everyone knows we have 6 papers in the mains examination. Each paper carries 150 marks. Now we are going to discuss about the paper 5. In paper 5 we have 3 sections. Section 1 and section 2 comes under the science and technology, and section 3 comes under the data interpretation and problem solving. In data interpretation we are going to discuss about so many areas like number sequence, number series, and different kinds of data which is represented in pie diagrams, bar diagrams, frequency curves, cumulative frequency curves, in all this, and also time and distance, time and speed, work and energy. Like we have to discuss various concepts which is concerned to the arithmetics. Mostly it gives a lot of problem solving and logical reasoning questions. And a very important, in every episode I am giving a information, I am repeating the same, that is you have to change your mindset from objective pattern to descriptive pattern. This is a very important instruction, because in prelims you have done the work on examination as just selecting answers, means right option, correct. So, but now we are going to write the answer in a descriptive manner, means you have to write the solution. So, we have to take a shift from answer to solution. This is a very important. Okay. And one more previous experience is, in this section there are 5 questions, each question carries 10 marks, but sometimes each question have 5 sub questions and each sub question carries 2 marks. That is a change or the previous examination experience, correct. So, anyway, whatever it may be, the examination marks or pattern, you have to prepare the concept in a. So, I am going to start with one concept. So, because this is a number system, actually there is a story which is a very familiar story about number system and importance of the number system, and especially importance of the number sequence. Okay. So, actually there is a kingdom, the emperor is in it, has a palace. So, one beggar visits the palace and just he prays the emperor, of course the king, sir, I am very poor, please help him. Okay, then he is a king, so simply, what do you want? I will give it to you, so ask me. So, then he said, at that time the king is playing a chess with his minister. So, then you want to utilize that consequence for his begging. So, then he asks, sir, so I am a beggar, I need not any kind of money or palaces or houses, whatever it may be, simply I need food, correct. So, give some grains. How much grains you require, how much quantity of grains you require, I will provide to you, ask him. You need 1 bag or 2 bags or 3 bags, how many bags you require? Simply he said, sir, so keep 1 grain in the first, in the first square. You are playing on chessboard, keep 1 grain on the first square, then make it double, means on the second put 2 grains, third double of it means 4 grains, next 8 grains, like you have to double the number of grains in each square. There are 64 squares. So, and 64, how much will come? That quantity of grains please provide me, like he said. Simply king feels that okay, this how much grains, maybe one bag or 2 bags. Now see, I have written that the story also here. The legend has it that inventor of the game called was chess told to name his own reward. His reply was along these lines: imagine a chessboard. Suppose 1 grain of corn is placed on the first square, 2 grains on the second, 4 grains on the third, 8 grains on the fourth, and so on, doubling each time to and include the 64th square. Okay, I would like as many grains of corn as the chessboard now carries. Means here, so it is when you count the total number of grains, now we will see it how it is. The first one, it is 1, correct? So 1 we can say as 2 power 0, second it is 2 power 1, third 2 square, fourth 2 cube, and so on up to the last one 2 to the power of 63, because we started with 0. This is the sum. Actually its value is, now I am going to say what is it. It's actually it's a GP, geometric progression. So its sum is, there is a formula called as A of r to the power of n minus 1 by r minus 1. So A is here, the first one is 1, correct? Okay. R to the power of n means 2 to the power of n, how many of them? 64 minus 1 by r minus 1, 2 minus 1, means its value is 2 to the power of 64 minus 1. So when you know the logarithms, that you can find a concept, that is 64 of log 2. Log 2 is 0.3010, means 64 3s means 12, 6 for 9, 19 point. It is 19.2 means 20. Means when you consider this value in this number, there are 20 digits. 20 digits means here more than trillion, maybe like Googleplex. How many digits are there? Means at that time, so that grains will be sufficient for the total people of that kingdom for 2 years. Then you can imagine that sum means how the beggar is intelligent. Just he use the concept of progressions, means number sequence. Is it interesting? Yeah. So now we are going to discuss about this kind of interesting concept, which is highly interesting, at the same time very useful in point of your examination. Now we will see. The number sequence is a progression or an ordered list of number governed by a pattern or a rule. Number in sequence are called terms. A sequence that continues indefinitely without terminating is an infinite sequence. So when the sequence stop for a certain numbers, it is called a finite sequence or finite series. So when it is continuously coming, there is no end, so we call it as an infinite sequence. Clear? Okay. So here I am going to discuss a few numbers like 6, 3, 10, 14, 15, one sequence, 4, 7, 10, 13, another sequence. Is there any relation between the numbers in the first sequence, or can you find it? No, correct? So we cannot call it as with a specific sequence of the first one. But when you consider 4, 7, 10, 13, its value is 4, 7, 10, 13 and on. So 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. So what the next number comes means you can say 16. What the next number comes is 19. Means there is a common pattern, common rule throughout the series. Correct? So this is called a sequence. The previous one is not a sequence, just it is a group of numbers. I understand what is a sequence and what is a group of numbers. A sequence will follow a certain rule and it follows a pattern. So that is called a sequence. Correct? Okay. Now find the missing terms of the following sequence. In prelims we have written this kind of questions, correct, in the number series 8, some gap is there, a missing number is there, 16 missing number is there, 24, 28, 32. So, now we will come from right to left. What is the difference between 32 and 28 means is 4, correct? And the difference between 28 and 24 is also 4. So, obviously, the next number has the same difference between 24 and that number, means 24 minus 4, 20, means here 20 will come. Now, we will check it whether it is the same pattern follows or not. The difference between 20 and 16 is 4, correct? Okay. So, what is the difference between this number and 16 will be 4. So, means 16 minus 4 is 12, correct? Now, it is a complete series now, observe it. 8, 12, 16, 20, 24, 28, 32 means here the number is increased by 4 units. Of course, later we call it as an arithmetic progression, means each number is generated by adding a fixed number, means this series has a common difference, that difference is 4. This is called one progression or one sequence, understand? For example, if it is given as 3, 8, 13, 18, 23, what is the next? You can say 3 plus 5 is 8, 8 plus 5 is 13, 13 plus 5 is 18, 18 plus 5 is 23, so 23 plus 5 is 28. So, the next number is simply we call it as a 28, understand. So, like there are so many series are there, so many sequences are there, we will discuss all those here to get a clear concept about the sequence and series. Okay. Now, we will see one more. What is the value of n in the following number sequence? 12, 20, n, 36, 44. What is the value of? Means here you have to find it. So, what is the difference between 12 and 20 is 8. 36 and 44 is also 8. Obviously, the difference between 20 and n should be 8, means 20 plus 8, 28, correct. So, 28 plus 8, 36, correct. So, what is the n value? N is 28, correct. So, like you can find the missing number or missing value in a sequence. So, maybe everyone feels that sequence is a very simple concept, correct. Now, we will see how it is simple or like. So, first one is arithmetic sequence, and I have to give the historical importance of this arithmetic sequence is Aryabhatta has invented this sequence, and so we call it as sometimes arithmetic progression also, sometimes we call it as AP also. The nth term of an arithmetic sequence and the sum of n terms of an arithmetic sequence was invented by our Indian mathematician called as Aryabhatta. So, Aryabhatta has written this information about this nth term and sum of n terms of an arithmetic sequence in his book called as Aryabhattiyam. So, Aryabhattiyam is one of the book, so concerned with the arithmetics. So, there this information is there, understand. So, this is a type of number sequence where the next term is found by adding a constant value to its predecessor, adding or subtracting. When the first term denoted as x1 and d is the common difference, then the difference between the consecutive terms, the sequence is generalized in the following formula: xn is equal to x1 plus n minus 1 of d. This is the formula for nth term of a arithmetic progression. Now, we will see, for example, let us take the previous question just now we discussed 3, 8, 13, 18, 23, correct. What is the next? This is the question already I explained. Is it an arithmetic progression or not? Yes, it is an arithmetic progression. We have add 5, then each one will come, understand. And the beauty or importance of this arithmetic progression is the sum of the extremes on both the sides will be same. Means first term of the arithmetic progression and the last term of the arithmetic progression sum is equal to second term of the arithmetic progression and the last but one of the arithmetic progression also equal. Means just observe it. 3 plus 23 is how much? 26, correct? 8 plus 18 is how much? 26. Am I correct or not? So, when you consider an arithmetic progression, the sum of extremes means first term of the first one and the first term of the from the last one, their sum, second term of the first one, and of course, the second term from the either side will be same. That is one of the important property. This property will be executed by only arithmetic progression. Okay. This is the most important property. Okay. And the nth term xn is equal to x1 plus n minus 1 of d. So, here x1 is the first term, n is the number of terms and d is the common difference, and d is the common. You have to remember this one. xn is the nth term, x1 is the first term, n is the number of term and d is the common term. For example, in this series you want to know 10th term. What is the 10th term of in this series? So, you have to find x10. Then what you have to do? What is the first term? That is a or x1. x1 is 3 and the common difference d is 8 minus 3, 5. So, you have to substitute and n is equal to 10, correct? Now, substitute this value. x1 is 3, n is 10 minus 1, d is 5. So, 3 plus 9 5s means 3 plus 45, 48 is the 10th term in this series. If you have any doubt, check it also. So, 3, 8, 13, 18, 23, 28, 31, 34, 37, 40, correct? Like you have to change, it is a 5, you have to change, sorry. You have to 23, 28 plus 5, 33, okay, plus 8, 38 plus 3, 43, correct? Now, observe it. 3, 8, 13, 18, 23, 28, 33, 38, 43. You okay, plus 5, 48. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 10th term is 48, means when you write by adding 5 also you got 10. Okay, if it is 10th term you have to find easily, but if it is, for example, I want to know 567th term of in this series, then how you are going to do? Can you write up to 567 terms? Not possible. So, you have to find the nth term of the arithmetic progression. This is a very important. So, are you understand? The nth term of an arithmetic progression is xn is x1 or a as your wish plus n minus 1 into d. This is the formula to find the sum. Okay. Now, we can say another one. We will say the nth term as a last term also. Sometimes we will use it L is equal to a plus n minus 1 into d. This formula also we are using to find the last term. Last term means nothing but it is an nth term of it. Okay. And we will see an example. Already what I said 3, 8, 13, 18, 23, 28, 33, 38 and so on. This sequence has a difference of 5 between each number. The pattern is continued by adding 5 to the last number each time like this. Now, observe it, correct? So, we shown this one on a number line. Okay. And a very important factor for this is when you consider 3, 8, 13. So, 3 plus 13 by 2 is 8, observe it. When there are 3 letters, say it is A, B, C. then B is equal to A plus C by 2. Here B is called arithmetic mean. Understand? This is one more important information. The arithmetic mean. The arithmetic mean is just average of the first and third elements if there are 3 elements. That is an arithmetic mean. Okay. And the common difference between means the difference between any 2 consecutive numbers. That is a arithmetic common difference. So, like you have to understand this one. And one more very important I will give here only to generate the formula 3, 8, 13, 20. Now, I am taking 1, 2, 3, 4, 5, these 5 numbers. 3 plus 8 is how much? 13. 11. 11 plus 13 is how much? 24. 24 plus 18 how much? 42. 42 plus 23 is how much? 65. So, the total sum is 65. Okay. So, now I am taking 65. You can write as 5, 13 just 16, 65. Okay. Now, we can write as 5 into 13, you can write with respect to these 3, 23, 3 plus 23 by 2, because 13 is 26 by 2. Now, why I am taking, I will explain it. What is 5 here? It is a common difference, correct? So, D. What is 3 here? The first term A. What is 23rd term? L by 2. This is the formula for sum of n terms, or you can write it as, see this D is 5, of course is coincide, you can say as n also, because number of terms is 5. So, n by 2 of A plus L, one formula, or you can say n by 2 A plus L is A plus n minus 1 into D, correct? So, we can say n by 2 A is 2A plus n minus 1 into D. This is n more formula to find the sum of n terms of an arithmetic progression. Especially for this number sequence, yourself only you have to derive the formulas. That is a very, very important logic. Clear? So, you learned 2 formulas. Those formulas are sum of n terms and nth term. So, first is nth term is I am saying with as an is equal to A plus n minus 1 into D, and sum of n terms Sn is equal to A plus 2 means n by 2 into 2A plus n minus 1 into D. These 2 formulas you learn it. When A, B, C are 3 numbers which are in AP, then arithmetic mean is equal to A plus C by 2, like you can say it. Clear? Okay. Now, we will see once again very clear mode. Arithmetic sequence A plus D, A plus 2D, A plus 3D and so on. This is an arithmetic sequence. Arithmetic series. So, what is the difference between a sequence and series? So, when you take it as addition of those terms, that is called arithmetic series. When you take the terms only, that is arithmetic sequence. That is the difference between the sequence and series. Here the first term is A, that is very important, and the common difference is D, correct? Common difference is D. How we are going to get a common difference? Means the difference of successive terms, means an minus 1. That is a common difference. And nth term an is equal to A plus n minus 1 into D. Here A is the first term, n is the number of terms and D is the common difference. Okay. And sum of arithmetic series Sn is equal to n by 2 of 2A plus n minus 1 into D. This is one formula, or you can say as Sn is equal to n by 2 of A plus L, where L is the last term. Then you may have to find what is the use of this formula. For example, you want to find the numbers from 1 to 100. 1 to 100, what is the sum? I will say as 50-50, means 5000 50 is the answer. How are I going to say this answer? Very simple, means now I am going to say the n by 2, correct. So, up to 1000 I said, for 100 values, n by 2 means here n is equal to how much? 100, 100 by 2, a is the first term 1, L is the last term, that is 100, means 100 by 2 of 101, or you can say as 50, means 101 50 is a 5050, correct. So, without calculation I added from 1 to 100 numbers. See how simple it is, like. So, if you want to do the especially addition, multiplication and different kinds of basic operations, then see this sequence is highly useful. For example, if you take it as the odd numbers 1, 3, 5, 7, 9 up to 100, what is its sum? 1 plus 3 plus 5 plus 7 plus 100, it is 10,000. I can say as 10,000 directly. How are you going to say this one? Because the sum of n odd natural numbers is n square. If you have any, check it. See, 1 plus 3 is 4, means 2 square, 1 plus 3 plus 5 is 9, 3 square, correct. Like you are going to discuss it. Now, I just give the information about the sequence. We discussed about arithmetic progression. So, now we are going to discuss some more progression, some more sequences in the next episodes. Until